Hi guys, welcome to this second video on the largest sum subarray problem. In the previous video I discussed a solution with a quadratic time complexity, basically a solution which iterates over all possible subarrays and then finds the maximum. In this video I will discuss Kadane's algorithm, which is an improvement when compared to the previous algorithm we discussed. And to explain this I will use an example. And the example I want to discuss is the example given here, basically the numbers -1, -2, 4, and 6. And so we want to find the maximum subarray. And so the way Kadane's algorithm would work is we would first look at this first element, which is -1, and we start with a value which is super small, which is basically you can't get more negative. And we compare it to this, and we say, well, is -1 better than that value? Yes, it is. So we choose our current maximum subarray to be -1. Then we compare the sum of -1 and 2. So we compare this to -1. And so this would be -3, which is less than -1. So we don't pick -3, we just keep -1. Then we go to the number 4. And we would compare the number 4 to -1 plus 4. So basically this part, but not including the 2. So 4 is larger than -1 plus 4. So now we don't pick -1 anymore, we pick 4. Then we will go to the number 6 and we will basically say, well, is 6 larger than 4 plus 6? No, it isn't. So we will pick 4 plus 6 to be the maximum subarray. And then we're finished, we're at the end. So the maximum subarray would be 10. And as you can see, this is correct, and we have found the correct solution for this example. And so we will now look at a implementation of the algorithm in code. And this is basically how you would implement this in Python. So I've defined a function known as max subarray, and we give it a certain array. And let's say that the length of this array is n. We then define basically a variable known as best sum, and we initialize it to be -infinity, which just basically means we make it super small such that no number is smaller than best sum. Then we also initialize another variable called current sum, which we will use to keep track of the sum in each iteration of the array. And now we start doing the same as we did in the example. For each number in the array, we will evaluate current sum, and we set it equal to either num or the current sum plus the number, and we take the best one. So once we have done that, we will go and compute the best sum, so the best sum we have seen so far, which is just basically the maximum number again of the current best sum we have and the new sum we have found. And so we take the best element and we repeat this until we're out of elements, and then we return the best sum over here. So let's evaluate the time complexity of this algorithm. As you can see, these are two constant time operations, and then we will have a for loop here, which basically takes linear time. So the time complexity of this algorithm would be linear, which is a significant improvement from last time. So now let's switch over to VS Code to see how this algorithm actually works. So I've actually implemented this algorithm in VS Code, as you can see, and now let's run it on these examples. So if you look at these three examples, it's better just to remove these ones from the previous tutorial because it will be easier to see. So yeah, if you look at these examples, for the first array, it implements, or it returns 8, which clearly, as you can see, is correct. Then for the second array, it returns 430, and if you look at this array, basically the maximum would be indeed 430, the entire array. And for the third array, the one example we just discussed would be 10, where we would basically have found all of the maximum subarrays. So as you can see, Kadane's algorithm does work, and it finds the solution within linear time, which is an improvement from what we did last time. So thank you for watching this video. If you liked it, leave a like. If you subscribe to this channel, that's really appreciated. I intend to drop more content like this in the future. Please also let me know if you would like to see any specific problems that you struggle with. That's it. See you in the next video.